We are going to look at density in this video. And I'm sure you've seen a picture like this or have seen, you've done this in real life where we are looking at substances that don't mix. So they form layers upon density. So we're going to find out later in this class what happens when do mix, right? So alcohol and water, they have different densities, and so we don't see those layers. But corn syrup and water, or this adding oil to it, they don't mix. They form layers based on their densities. So we are going to look at that, later in class. Right now, we're just looking at how things form layers based on a density difference. In this demonstration, we see a dense liquid at the bottom, a lighter liquid here, and then at the top, it looks like we have an oil. So we see some solid items that are floating in the different levels. So we know that the least dense thing is on top, and then the most dense thing is on the bottom. And we know this intuitively, right? Like you go to take a boat out in the water and you throw an anchor overboard, it's heavy, it's really dense. And that's going to sink. And you're not going to throw a piece of styrofoam out to anchor your boat, right? Because it is not dense. It's going to float on top of the water. So what is density? We're going to calculate density doing some different calculations, but we're also going to right now just look at the concept of density and the trends of density in this little video. All right, let's watch this experiment here. We've got a glass of water. We put in some water, some food coloring, and mixed it up. Now they're pouring in some very viscous corn syrup or honey. Added a little bit more water to that to give us about the same equal number of layers. And notice that this is some oil. Doesn't matter, sunflower oil, olive oil, canola oil. And it rose to the top. So we see very clear layers here. They don't mix. They have different densities and are not mixing. Now we're going to add in some objects into these layers. First we have a bolt. And notice that it goes right to the bottom. It is the most dense. And then we have a grape, which is about the same size as that bolt. But notice that, and I'm going to pause this right here, the grape stops right here. So it doesn't float on top of the water, but it doesn't sink to the bottom of that oil. It's about the same size, but there's less particles that are squeezed into that grape. So even though it's the same size, there's less particles in that grape. So it is less, it's less dense. It is, we'll say floating, but it is more dense than the water, but less dense than the oil. And let's see what we've got next. We've got this cap, again, about the same size. It's more dense than the oil, but it's less dense than the water. And then finally, we have this foam. Again, same size. Its mass in that same amount of volume area is less. Now let's go back to this image again, but really think about what is happening to the particles and the things that we can't see. But imagine the things that help us understand the concept of chemistry. So, like we said, all of these things are about the same size. So, about the same size as in the same volume. So, I kind of depicted these with the same size squares. Now, we said that this one was more dense. The particles, there are more particles and they're arranged tighter. So I depicted that by kind of showing that we've got, let's just say here, 1, 2, 3, 4, 8, 12, 16. We've got 16 particles in this box, as opposed to the grape, which is less dense, because let's say they've only got 12 particles in that same amount of volume. And then we have our cap here, let's say less particles still, so it's less massive. Not only is it less dense, but it's less massive for about that same size. So we've got a smaller number of particles and then our piece of foam, again, about the same size, even less particles. So less mass over the same amount of volume is going to give us something that's even less dense than the other three objects. So this just kind of gives you a conceptual understanding of those four pieces. Now, let's think about the three liquids that are here. We've got our viscous corn syrup, we have our dyed water, and we have our oil here. Because the bolt is the most dense, it is sunk, so it is more dense than the corn syrup. So the corn syrup must be less dense. Again, these three liquids are about the same volume. So the difference between these three liquids, again, in that same amount of space, we have the water has less particles for the same amount of volume than the corn syrup does. And if I looked at the bolt versus the corn syrup, we can see in that bolt has more particles per volume. So it is more dense than the corn syrup. The grape compared to the water, we can see that there are less particles, right? That grape is more dense than the water. There are more particles, more mass for that same amount of volume than the water has. We can see the water, let's say we've got 3, 6, 9, 10 particles in that volume versus this has 12 particles per volume. So that grape is more dense. So hopefully that has helped you to kind of conceptually understand what's happening here. Density is mass divided by volume. And in this case, what I kind of showed you visually, even though we can't see these particles, is that we're able to take the number of particles and divide it by the shape. So if I were to compare the mass of my oil here, if I did 1, 2, 3, 4, 5, 6, 7, 7 divided by my shape, my square, whatever the area is, compared to my foam, 1, 2, 3, 4, 5, 6. 6 divided by that area. Let's say the area was 1 times 1 times 1, so the volume would be 1. So 1, 2, 3, 4, 5, 6, 7 divided by 1 versus 6 divided by 1. This is less dense. Let's say that I wanted to compare the density of this object versus this object. We would say, well, we have again, the number of particles per volume or per the shape. So 1, 2, 3, 4, 8, 12 compared to 4, 8, 12, 16. Well, this one is more dense. There's more particles in a given amount of space. So more dense, less dense. But let's say that I had this guy in a larger space. Which one of these would be more dense? Well, these are going to expand, right? Or let's just say that I've got 1, 2, 4, 8, 12 particles, and let's say this is double the size. So 2 times 2 times 2, length times width times height would give us our volume. So 2 times 2 is 4 times 2 is 8. So I've got 12 divided by 8 versus 12 divided by 1. This is going to be more dense than this one. It will be less dense. That will give me a smaller number. There are less particles in a certain area. Once that denominator, that shape, that volume becomes bigger, then our density becomes smaller. This is a fun simulation to kind of practice what we've been learning and calculate the density of these different objects. If you take these objects and let's say I put it onto the scale to get its mass, 2.5 grams. And then to get its volume, notice that my starting point here is 25.5 milliliters. So when I take this and I pull it all the way underwater, it goes to 29.6 milliliters. I'm going to subtract the difference in those two. So 29.6 minus 25.5, and I'm going to get 4.1 milliliters. as my volume. So to find the density, I'm going to do 2.5, which is my mass, divided by my volume. And again, we said that is 4.1. And I would get a density of 0.61 grams per milliliter. 0.61 is smaller than the density of this liquid, which is 2.5, so therefore it floats. Now let's check out gold, for example. Let's say I have a piece of gold. Notice that this object sinks. Let's find out what its density is. I'm going to put it on the scale, and we get 40.53 grams. And again, my starting volume is 25.5. So to find the volume of the lead, we do 27.6 minus 25.5, and I get a 2.1 milliliters. So we're going to do our mass divided by volume. So 40.53 divided by 2.1, and we get a density of 19.3. That is greater than the density of the liquid, so it will sink. You can do the same thing for the iron, the lead, the wood. And again, if something is sinking, that means that there are more particles in a given volume than something like wood that is going to float. And so you could take and measure the mass of this, 1.95 grams, divided by the difference of 28.5, that would be 3 milliliters. So 1.95 divided by 3, and that would give us 1.95 divided by 3. Again, about 6.6, meaning it will float. So I will put the link to this so you can do some more practicing. And you can also change the density of your liquid to figure out what the density of this object is. And then how does that change whether it floats or sinks depending on the density of the liquid. So I'll put that link right underneath of this video, and have fun exploring.